All right, here we go. Unit 3 test review. This one is going to be over force and motion as well as Newton's laws of motion. So lots of different things we're going to be covering. And then we're going to step backwards and look at a couple of, or remind you of a couple of chemistry facts that you may or may not need on this upcoming test. So let's just, in no particular order, let's just deep dive in. So net force. Remember, when we're calculating net force, you have to add the sum of all forces that are acting on the object. A lot of times it'll be a word problem. You know, we have one group pulling one way and two groups pulling the other way. So you add the two groups pulling one way, and then the opposite way, you subtract that from the others, and then you have your net force. Sometimes your net force results in zero, which would be a balance force, or which would be, there would be no movement. Or it could be constant straight line movement. So a couple of different things there. But in this case, let's just look at if we have 5 newtons that direction and 4 newtons, we know that it would be a net force of 1 that way. East, to the right, whatever this direction is in your word problem. But there could be another force acting on it. So now you have a total of 7 pulling or moving this direction, 5 going this direction, so your net force would be 2 this direction. So there's your net force review. So let's again go back in time for physical chemical change. So remember, when we're talking about chemical change, we're talking about the acronym, please excuse coughs, burps, sneezes, or chunks. So precipitate, endo or exothermic reaction, color change, bubbles, smells, oxidation, what else is there? Combustion. So it's those things. So if there's that involved, then it typically is a chemical reaction and a new substance has formed. Physical change, we're looking at tearing, shredding, mixing, any of the phase changes for water, those types of things. That would be physical. Chewing, physical. Digestion, chemical. So just make sure you can differentiate between between physical and chemical change. What does a chemical equation tell you? You should know this by now. A chemical equation pretty much just tells you the atoms and elements involved in a chemical equation. Doesn't tell you anything else. You can't discern any other information from a chemical formula or chemical equation other than the atoms and elements involved and how many, right? We have R, we have Y, we have P. Whatever atoms and elements are on the reactant side is going to be the same atoms and elements on the product side, just rearranged. That's it. Reactive groups. We have 2 of them that are the most reactive groups on the periodic table. We have your metal group, which is group 1, because they have 1 valence electron that it wants to get rid of to form a positive ion. It very rapidly wants to get rid of that valence electron so it can have a full octet or a full valence shell. And then you have your group 7, which is your nonmetal group that is the most reactive. We call those the halogens. And they have, typically, will have 7 valence electrons in their outer orbital, and they just need 1 more. They very badly want that. So a lot of times, Na, sodium, will mix with Cl, which is chlorine, to make sodium chloride. And that is a very common compound that will come together. So just make sure you remember groups 1 and group 7 are the most reactive groups on the periodic table. So one of the most important things, let me have a seat here. Sorry, a little bit of noise. Listen, one of the most important things you can do when taking a test is bring your common sense with you. Gotta have it. You have to have common sense when taking a test. Just because you're taking a test doesn't mean it's time to forget the things you know about life before you end up taking that test. So know that you should know from just being alive on planet Earth and being in a car and you see a big truck, you know that it's going to take longer for that truck to slow down than it is for, a small car. You know that Big Mama in a wheelchair, if she's going, 5 miles an hour, is going to take a whole lot more power and strength to slow down than Little Mama in a wheelchair. It's common sense, people. You got to have this common sense. So make sure you do realize the differences of what happens when you have something heavy and you have something light. Do you want to get hit with a tennis ball or a bowling ball? Come on, common sense. Clearly, the tennis ball, because it's not going to have that big of a force. Force equals mass times acceleration. So you got to think of these things when you are, keep your common sense and your wits about you when you're taking these tests and you're answering these test questions. So hopefully that'll help you. And when we're also talking about common sense, friends, I've said this before, let me say it again. The importance of reading your test question cannot be understated. If you don't read the test question right, honors students, you will miss said test question. Pretty much ask any of you. Yeah, I'm talking to almost every one of you. So read the test question right, read it right, and then answer it. Please, I implore you, do so. Okay, now I'm done, speaking to your soul. Let's get back to the review. All right, rocket propulsion. So we're talking about when you think of rockets and you're thinking about Newton's laws of motion, think third law. Think action, reaction. So when a rocket is on planet Earth looking to leave the Earth, what happens is it fires its rockets. It fires its boosters. There's gases and force being pushed down on Earth. And that is the reaction. The reaction is the rocket then leaves Earth. So those gases are pushing down. The rocket can now, with enough force, to have that rocket go upward. So downward force, upward force. That's the action-reaction pair that allows that rocket to leave Earth. Let's go distance time graph. So we have our distance and we have our time here. Remember that there are 3 different constant speeds here. Slower constant speed, average, and super duper fast, right? The greater the angle upwards on a flat line like this or a straight line on a distance time graph, the faster the constant speed. So there's those lines. Let's now look at this line. A flat line like this on a distance time graph means the distance is not changing. The distance is staying the same. So we would call this at rest. So here's a little story I can tell you. I drove to the store at a constant speed. I shopped in the grocery aisle or the grocery aisles with my wonderful mask on, and then I drove the heck home. Returned to start. That's a great story that you can tell on a distance time graph. Know that everything changes if this becomes a speed time graph. It's not the same story anymore. I accelerated at a constant speed, I stayed at that constant speed, and then I decelerated. Both of these would be considered acceleration, right? Both of these would be considered acceleration. This would be considered constant speed. So just make sure you understand the difference between a speed time graph and a distance time graph. So when you're answering those test questions, definitely look at your x-axis and your y-axis and know what it is you are looking for before you go to even begin answering the question. We are trucking along, people. So when you have third law of motion, Newton's third law, and you have first law of motion, there's a seatbelt example that you need to be able to differentiate. You have wearing a seatbelt versus not wearing a seatbelt. Not wearing a seatbelt is a great example of Newton's first law of motion. We call that inertia, right? Objects in motion staying in motion. Objects at rest staying at rest. Inertia is an object's tendency to resist its change in motion. So whatever the object's doing, the object will continue doing until an unbalanced force acts upon it and accelerates it or changes its motion. So definitely knowing that if you're not wearing your seatbelt and you're in a car wreck, your body will continue going in the direction that it was going. So if you're going forward and you stop suddenly, your body and everything else in the car is going to keep going forward. You should know this. That's part of that common sense I talked to you about earlier, because every one of you is driven in a car. Okay? So make sure you understand that. Wearing a seatbelt is a little bit different, because now we're talking about Newton's third law of motion, action, reaction. So the action is you're jolted forward, but the reaction is that seatbelt pulls you back. Forward, backward. So action, reaction, wearing a seatbelt is an example of Newton's third law of motion. So, and then one more that since we're already here, let's talk about F equals ma. Force equals mass times an acceleration. This, friends, is a triangle that you can use. And if you know how to use triangles, makes your life easier when you're talking about solving these equations. So you're reading the word problem. If it gives you an acceleration, so we have F, M, and A. Let's say it gives you an acceleration of gravity. We already know that that's 10. And the mass is 50 kilograms. Well, you take that 50, you times it by 10, that gives you the force. It's that simple, okay? But remember, though, that if they ever give you the force in the question, let's say 100 newtons was acted, what the force was acted upon an object, then you know that that force will go in the house. And so you'll have M or A that you will be dividing by. So knowing how to manipulate these questions is really important. But the good news is this is very simple math. You're either doing simple multiplication or simple division. So you guys are well past that in your math journey. So I expect you should be able to be just fine when answering those types of questions. Speed, velocity, and acceleration. Know that speed equals distance over time. 60 miles an hour. If you're driving 60 miles an hour for 5 hours, you know that you're going to be able to go 300 miles. It's math. So know that speed is distance over time. Velocity is the same thing. It can also be found with distance over time, but it also needs one more thing, a direction. So our example of speed is 60 miles per hour. An example of velocity is 60 miles per hour north. So you can change the same speed and turn it into a velocity just by giving it a direction. So velocity is speed and direction. And speed is distance over time. Okay? And the last one is acceleration. Super important concept. Knowing that acceleration is speeding up or down, or changing direction. Meaning, I could be going 60 miles an hour in my car. I'm in the middle lane. I want to get in the right lane because my exit's coming up. So I'm staying 60 miles an hour. I turn my wheel and I go into the next lane. My speed never changes, but my direction changed the moment I turned my wheel in my car, so I accelerated. I accelerate when I come to a stop. I accelerate when I go from a stop to start. That's acceleration. Tons of different types of acceleration. Acceleration changes motion, right? So knowing that acceleration, an example of acceleration is speeding up, slowing down, and or direction change. Any of those three. And let's talk about friction. Friction is a negative force. So when you're thinking about a balanced or finding net force, if you see friction involved in the question, know that you will be subtracting that force of friction from the forces to figure out what that net force will be. Friction slows everything down. It slows down cars when they're driving. Air friction, and then the friction from the tires on the ground. When I roll a ball, the ball will eventually stop because of friction. Friction slows everything down. We call it a negative force. So just make sure you know when you see friction, you know that there is a negative force involved. Excuse me. And we're almost done, friends. Balance force. So balance force can be a straight line, constant speed. Balance force can be not moving. Or straight line, constant speed can also be a balance force. Both of those two. And then we have unbalanced force equals acceleration. I've already discussed this. That's a very important topic or point to know, especially for the test you're about to take. So unbalanced force equals acceleration. And then atomic particles, don't forget, we have neutrons and protons in your nucleus. And the only charge coming out of that nucleus is a positive charge because of the protons. Then you have your electrons around the outside, which are practically weightless, unlike the 1 AMU particles inside your nucleus, and they have a negative charge. And the positive charge and the positive charge of the protons and the negative charge in the electrons around the outside, they attract each other. Thank goodness, because if they didn't, our atoms would blow apart. But it's the middle of your atom, that marble in the, that marble in the middle of the 50-yard line on, in Dallas Stadium, and those electrons around the outside. That's what keeps them together. Is that that opposite attraction of positive and negative. So just make sure you remember that. Remember that for the test, and also remember that for STAR. And then I can't reiterate more on Newton's second law. Force equals mass times acceleration. That is a sports law. There's usually a lot of sports questions involved with force equals mass times acceleration. I can accelerate my mass of my fist and punch and apply a force to this screen and, knock my computer around, because that is a great example of force equals mass times acceleration. That's your wonderful review for your Unit 3 test, Force and Motion. See you guys in class.